Dear students, you will find here certain hints in electrochemistry and which may serve you as a ready reckoner or hints, or you can call it as a points to be kept in mind. And this is related to what is known as electrochemical cell, also the electrolytic cell and the conductivity. So please go through these hints and this will be of much use to you. Electropotential cell, spontaneous reaction, Nernst equation. And as we find that this N in the Nernst equation represents the number of electrons involved in the change, and these X and Y are the coefficients raised to the reactions. And E cell is related to Kc, and free energies are also related to Kc in this way. And then all this, if the outcome of all this is, as per E0 or E0 value, a metal having more electronegative reduction potential is a stronger reducing agent than hydrogen, while a metal having more positive reduction potential is a weaker reducing agent than hydrogen. Very important. And the charge on 1 mole of electron is equal to 96,500 coulombs per mole. That is equal to 1 Faraday. And this, as we know, depends on the Faraday's laws of electrolysis, first law as well as the second law. And then we need to go through the outcome of this changes are the reaction delta G, E cell, and also the equilibrium constant K. If you find here delta G naught is equal to minus RT log K, K is of course equilibrium constant Kc, and E naught cell, just as we have taken up, is equal to RT upon NF log K. Of course, it is represented in natural logarithm to the exponent E. And then here is the outcome of what we have learned. If K is greater than 1, delta G is less than 0, and E cell is greater than 0, reaction is spontaneous under standard conditions. Product is more abundant at equilibrium. Similarly, if K is less than 1, delta G naught is greater than 0, and E cell is less than 0, the reaction is non-spontaneous under standard conditions. And if K is 1, delta G naught is also 0, and E naught cell is 0, the reaction is at equilibrium under standard conditions, and reactants and products are equally abundant. So this is quite important outcome of the relation between delta G, K, and E naught cell. Now, next we shall get about an idea about the Kohlrausch law. Kohlrausch law, क्या होता है? It is given here. So please go through it. That it represents also depends upon the migration of ion, independent migration, which occurs in infinite dilution, and that gives you the molar conductivity. And here are the important formulae or expression to find out the conductivity of a solution at infinite dilution. This represents at infinite dilution the conductance of cation plus conductance of anion. And this represents the number of cations and the number of anions. And she is, as we know, is known as hydrogen electrode. And here is the formula. And therefore, and these are the specific resistance. And what is unit? Unit rho is equal to 1 upon copper, where S is called Siemens. And this is also an important expression regarding about conductivity, conductance G, and the cell constant, which is L upon A or L by A, और इसका unit ये है. Similarly, so a few more expressions are there which we need to understand. Molar conductance is the conductance of a solution containing 1 mole of a solute in given volume. This unit, the unit is Siemens per square centimeter mole inverse, and degree of ionization ka. This is the expression which is very commonly used, and it will be of much help to us in solving several problems relating to conductance, electrolytic cell, as well as the galvanic cells or the cell constant, etc. Okay, thank you. Please go through this and keep it in mind. That would help you a lot in solving many problems relating to electrochemistry. Thank you very much again. Please do subscribe to our channel.